The next speaker is Dr. Andre Nel, will address the sunflower Optimum fertilizer. Andre, I think I wish to mention to the audience that when I started as a young administrator at the Oilseeds Advisory Committee, Andre was a well-established researcher on sunflower. Welcome. We're looking forward to your presentation.
Yeah, Mr. Chairman, thank you for the invitation, especially as I've been out of the sunflower world now for more than 6 years, and you still think I can add value to your conference. Okay, my talk is about fertilizer application of sunflower. And obviously, we want to do the correct thing at the correct time with fertilization. But this is a graph, a bar graph that I've drawn with info from Grain South Africa. And this is sunflower budget for coming season. The total cost of production, you can see it's between 6,200 Rand or 6,300 Rand up to slightly more than 8,000 Rand per hectare, depending on your target yield. And this gives a breakdown of the different items, the percentage of that total cost, more or less. And as you can see, there's two of them standing out. Fertilizer, 36%, and fuel and repairs, that's your mechanization, is about 30%. And the rest, all below 10%. And it's quite interesting. Other crops look quite different. Seed for some of the other crops are quite high. But there's another thing I want to point out here in that is this fuel and repairs, we can reduce it quite a lot. If you have soil that you can apply no-till on, you can reduce that cost by about 60%. So if this will drop, it will even push this a little bit up, and everything else will also increase. And then fertilization would be the single most important input item for sunflower production. And I think we should keep this in mind. Now, it is a fact that sunflower is a unique crop. It's unique due to its root system. And people who studied it described it as it's got a strong taproot that typically penetrates the soil 1.5 to 2.7 meters deep, occasionally going down to 4 meters. And that is quite deep. It's the deepest I've seen for any crop. And obviously, your soils should be able, or there should be no barrier or obstruction in the soil. Now, it also has a strong lateral root, or strong lateral roots developed from the taproot, which diffuse almost completely throughout the top 0.6 meters. I think it's much more than what we can say for other crops. The root system of sunflower can be considered explorative. A large volume of soil is explored with a combination of thick and thin roots. Very important. And I think this is the main reason why we say sunflower is drought resistant. Drought resistant. It can take up far more moisture from the soil than any other crop. In a particular study in the USA, they compared it with sorghum. And on that soil, sunflower, they wet it all white and let it grow, and then withdraw all rainfall and water from it. And sunflower was able to take up more than 45 millimeters more from the soil than what sorghum could. But there's a disadvantage to it as well, and that is it makes accurate fertilizer recommendations very difficult. And you will see as we progress. Now, just to show you photos from that I've took some time ago, a long time ago. Top, there on the top, you can see this is drought, severe drought. Even in the morning at about 8 o'clock, I think this picture was, no, this was taken about midday, but it was verlep very early in the morning, and even the weeds died off. There were a couple of small weeds, and they simply couldn't take it. The drought was far too much for them. On the bottom here, this is our very high clay soils, and you can see what the clay soils does. It cracks, starts to crack. And one particular one I found was in this district of Welkom. Now, those of you who knows the northwestern Free State, it's very sandy soil. And on top, it's about between 6 and, say, 7 to 9 percentage clay. And then it increases slightly, or to about 15-16% in the subsoil. And even in that soil, sunflower was able to produce cracks between the rows. And that was extraordinary. I've never seen it in anything like it on other crops. Okay, there's one very important thing, and that is with sunflower, if you grow sunflower, and that is the acidity of your soil. The pH should be above 4.5. I think Kobus mentioned 5.5. And this is what happens if you grow sunflower, try to grow it in a soil that the acidity or the pH was about 4, slightly higher than 4. Here was supposed to be a row, and this is the only survivor. And look at it, it reached maturity, and it's still a minor. Okay, the acid saturation should be above 15% if you want to grow it. Just another way of measuring it. I think it's more of accurate measurement. And this picture tells it all. If you look at the 3 pots, the one on the left got nitrogen and it got phosphorus. The one in the middle only got phosphorus, no nitrogen at all. And the plant, or the pot on the right-hand side, got no phosphorus, only nitrogen. And if you notice, this plant looks slightly better than that one. So phosphorus is a very important plant element or nutrient, but of course you need some balanced fertilization to get a proper plant. And there's the white rust that she was talking just now, she was mentioning just now. Okay, this is the uptake and removal of nutrients by a sunflower crop. And this is usually the starting point when you start to fertilize. And if you look, this is our local one. If you look at this particular table from different parts of the world, you start to think, are we really talking about the same crop here, or are we talking about different crops? For instance, the nitrogen, here we say it's about 35. I've seen tables where it's up to 50. And there's some slight differences here. And potassium is a complete, well, we don't know what to say about it. It's confusing. If we put it into rands, express it, the uptake and the removal of it, you can see that sunflower removes quite a substantial amount of nutrients, plant nutrients. If you have to replace it with fertilizer, and if you just remove the seed, it's about 1,100 rands per hectare that you remove with your seed. The similar or the same number for maize, figure for maize is about 700 rand. So sunflower use quite a lot of plant nutrients. Obviously, a lot of it stays behind on the field, luckily. And you can see, but the total amount taken up by sunflower is close to 4,000 rands per hectare for a 1 ton crop, 1 ton seed crop per hectare. Okay, let's do a look at the phosphorus guidelines. I think this is really much sorted out, and this is what we recommend. A lot of work done in the past, in the 70s and 80s on phosphorus, and in the 1990s, and this is the result of it, and it's straightforward. You look at your soil analysis and your target yield, and you've got a good idea of the amount of phosphorus that you have to apply. And yeah, this is sorted out. Yeah, just the same thing to emphasize the phosphorus. If you don't apply phosphorus, you might end up that way. Potassium, this is the potassium guidelines, and I was told by people who looked at it that this is merely a theoretical guideline. For a potassium deficiency haven't been seen in South Africa. And I've read it in a book of America, North America, the USA, never been reported, a potassium deficiency. Now it's significant that Kobus mentioned this morning that he found an interaction with potassium and phosphorus fertilizer. Kobus, am I correct? And maybe that's something to look into in the future. Maybe we're quite wrong. We do need to fertilize. For a lot of our soils are above 80, and then we usually say that we don't need to fertilize with potassium. Another thing of sunflower is that it can take up a lot of unneeded potassium and deposit it on the top of the soil, and eventually it will go into the top layer of the soil, and you can even enrich the top layer or the top horizon of the soil, and it's from taking up potassium from deeper layers and leaving it on the soil surface. And we've seen it in no-till, where we've applied no-till and sunflower 2-3 years, and you can measure it. You can see that there's an enrichment in the topsoil. So sunflower is mining a lot of potassium from deeper layers in the soil, depositing or leaving it on top. Now, this is what a potassium deficiency is supposed to look like. You can see yellowing of the leaves from the tip inwards, more or less. And if you find it, maybe we should have a look at our field, see if we can see something. And I'll quickly go to some micronutrients. There's only 2 of them that are important. Molybdenum, but it's not needed. So if you're a farmer and a salesman tried to sell you some muti with molybdenum in it, don't buy it. The seed companies usually apply a mixture of fertilizer to their mother plants where they produce their seed, or even a coating on the seed, and that's enough for a follow-up crop. Now the thing that is a bit of a problem is boron, and we've seen deficiencies usually in higher rainfall areas. Eastern Free State, it's quite often that you see it from time to time in western parts. And what is quite unique, there's an interaction with the water supply or the rainfall. And deficiencies usually develop during periods of drought, or ironically, also with a lot of irrigation. The theory about the drought thing is that the top layer of the soil dries out. Boron is most likely associated with the little bit of organic material we've got in the soil, and the crop only can take up boron from deeper layers, and it's not been able to take it up from the top layer, and then a deficiency might occur. And we've also seen that the deficiency starts to develop during a drought period, and there's rainfall again, and then it disappears. So interaction with rainfall. Now, cultivars may differ in their sensitivity. We found it. I've worked with some breeders in the past, and if they get some seed especially from Eastern Europe, I remember if they plant it in our soil, cultivars and material, genetic material, almost all of them start to develop boron deficiency symptoms. Now, the ideal is to apply boron only when a deficiency appears or develops. Otherwise, you're wasting money on the one hand, and boron is unfortunately, one of those elements where the deficiency and the overdose is very close the thresholds are very close. So it's been said that if you apply 2 kilograms of boron per hectare and you try to produce a bean crop, after that you might destroy your bean crop. The boron might be toxic, reaching toxic levels in the soil. And Mr. Chairman, last week I attended a meeting of Fertilizer, and it was said at that meeting that from next year sometime, I think it was June they mentioned, the use of boron will be prohibited. So I don't know what we're going to do in future with our sunflower in this respect. Now this is a boron deficiency developing. You can see the upper leaves. Here's the head on the right-hand side. And these upper leaves are very small and they are very soft, almost like a piece of cloth in your hand. And it later on develop into, as we've seen, the head broken off. The moment the head starts to get a bit of mass, it's too heavy for the neck and it just broke off. And it often looks like a very clean cut. If somebody has walked into your field and cut the heads off completely. There's just another example. It broke off a couple of days before and you can see the head dying. Now, unfortunately, at this stage, it's far too late to do any correction of this problem. Now, nitrogen is a bit of confusing. For a lot of countries are trying to refine their nitrogen fertilization by simply doing a calculation. And they use soil tests for that. You have to take a soil sample before you plant, have it analyzed and see how many nitrate is in the soil. And then you have this formula that you can use your yield target, 1 ton. In this case, the N content is about 40 kilograms per ton or whatever it may be for your country. Remember, I said up to 50. And then you can calculate, and your soil measurements say you've got 25 kilograms of nitrogen in the soil, then it's easy to boil down to 15 kilograms of nitrogen that you have to apply. And some countries even have a credit for the previous crop. If you have certain crops, they say you can take, say, a 20 kilograms or 10 kilograms or whatever into account in your calculation of your fertilizer rate. Some countries, I've noticed, Brazil, one part of Brazil, they said a straight 30 kilograms per hectare. That's it. You don't need more, you don't need less. I've seen, I think it was Poland, recommended 60 kilograms per hectare, and their yields they report in that same article was more than 3 tons per hectare. So it's quite different for different areas of the world. And if you read some of these articles, they will say, well, we don't need to apply any nitrogen in this case, or in our area, the soil supply. Remember, the nitrogen has to come from the soil, what is in the soil, plus your fertilizer. And our soil supply is so high that we do not need any fertilizer. Or you might read that our soil supply is enough for 80% of our target yield. So you only have to top it up a little bit. And this is our guidelines, South African guidelines. And it's a bit confusing. If your target yield is 1 ton, we say that you can apply from 0 to 40 kilograms per hectare. Now, 0 is quite far from 40. There's quite a big increase. And I'll show you how I think this value was or these values was calculated. And I think that we, with experience, know that if you have a clayey soil, you're probably closer to 0. If you have a very sandy soil, you're probably more to the 40 kilograms per hectare kind of way. Now, I've done with an old colleague of mine, we've started to look into the nitrogen fertilizer trials of South Africa done in the past, and most of it was done by Fertilizer, the Fertilizer Society of South Africa, and they started in 1968 was the first one, and they continued. They stopped their research in, I think, in the mid-80s, 1982, 83 more or less. And then there was here and there was a trial conducted with fertilizer, and we took all those data that was available and we calculated for them the optimum. First of all, we looked, was there a response to nitrogen fertilization or not? And surprisingly, only 25 out of the 50 had a nitrogen response. So half of the trials in the past said you need no nitrogen for nitrogen fertilizer for your fertilizer crop. 25 had, and we calculated the optimum nitrogen rate. Now, the optimum rate is where your last rand that you spend on nitrogen fertilizer just give you 1 rand of seed yield back. So, and we've plotted that optimum yield versus the nitrogen application rate, the optimum rate, and you can see there's a very weak relationship. So if you have an optimum yield and it's your target yield for 1 ton, you can say, well, I have to, if I'm in the middle more or less, I have to apply, say, about 25 kilograms, but you can see there's a large, quite a lot of variation. And that's where that number 0 to 40 kilograms probably originated from. So we are quite unsure what to do. There's no good relationship. But what we did is that we read an article written by a guy from Canada, a 1996 article, quite old. And what he did is he said, listen, I've developed a method to improve on the accuracy of calculating or predicting the nitrogen fertilizer rate. And what he did was develop the delta yield. Now, what is delta yield? Delta yield is the increase in yield brought about by the application of nitrogen. So how do you do it in practice? If you have a field, you're a farmer, you apply a strip or only part of your field, you apply no nitrogen fertilizer. and that represents only the soil supply. The rest you apply as normal, as you wish. And then you can harvest at the end of the season. You can compare the yield where you applied no nitrogen with where you applied nitrogen, and that is the delta yield, the difference between that two. And we've applied this to our results that we've got, and we found, I think, a fairly good relationship. So if you know what your soil can supply, we can predict rather quite accurately, I think, what you would need to apply to reach your optimum yield. And but unfortunately, that is knowledge that you need before you start to fertilize. It's hindsight, unfortunately. And we know from one season to the next season, your yield drops and increases. It fluctuates. Now, nitrogen fertilization is almost a moving target in the dark. You're always off target. But at least it can give you an idea what happened in the past. Was I correct, or how far from the target was I? Now, just to show you the effect of nitrogen, this is a trial I've done. 0 nitrogen, 2.1 tons per hectare, and the crop looks quite good. The plot on this side had 120 kilograms per hectare, and we had 3 tons per hectare. And you can see the growth of this crop. And well, that one also looks quite well. And but there's quite a difference in the appearance. And one of the things of nitrogen is that it promotes leaf growth tremendously. This is the 2 leaves from those 2 plots. More or less the same leaf on the plant, and you can see the size of the leaf. This one is much smaller, 0 nitrogen, and this one is quite large, almost, I think, about 3 times the size of the small leaf. Now, one of the things of nitrogen or recommendations, it's often said in recommendations, don't over-fertilize with nitrogen. Don't over-fertilize. Why? Because if you have large leaves, you only increase the leaf size for transpiration, and you will consume your available moisture quite fast, and you might run into a drought. Very important thing, I think. Another problem that was mentioned, often mentioned, is that plants are so heavy, the top growth are so heavy, they lodge very easily. And it can promote, apparently, certain diseases, and I think we need to have a look at that. What diseases is it? So, but the French did develop a very novel way of predicting the fertilizer need for their farmers. And they call it heliotest. And those of you who can't read French, let me explain what they are telling you over there. They do it just the opposite way of this delta yield business. They have the farmer plant his field, and they apply nitrogen only in a strip across the field to their crop. And then they keep close watch of their crop. And the moment they can see a visible difference between the strip where the nitrogen was applied and the rest of the field where no nitrogen was applied, they take down the growth stage. And it's simply by counting the leaves that is larger than 14 centimeters in length. And then they have a table that you consult, and something like this, and they would say, listen, what's my leaf stage? It's a 7 to 8 leaf stage, and my target yield is 2.5 tons. By the way, they use quintals. It's 100 kilograms, quintals. I've got 25 quantals per hectare is then you need to apply 30 kilograms of nitrogen. If I'm in the 9th to 10th leaf stage, and your target yield is to apply no nitrogen. So, and the question was, is this a reliable way of doing things? And interestingly enough, there was a couple of Swiss people who tried it out, and they said they had success 80% of the time with this way of looking at nitrogen fertilization. So quite interesting way. I never learned if their farmers adopted it, if they are still applying it. Yeah, but it's one way of doing it. And this is what it looks like. They simply issue you with a disc on a plastic sheet, and you look at your stage, growth stage. Over here, there's your plant, the growth stage, 9 to 10 leaves, and 40 quintals, 4 tons per hectare. You need to apply 80 kilograms of nitrogen per hectare. And obviously, it's linked to your target yield. And just have a look, they only start at 2 tons per hectare, much higher than our yields. Okay, Mr. Chairman, I'm almost finished. They say at a certain age, when you reach a certain age, you give advice, whether you were asked for it or not. And I'm now at that stage, Mr. Chairman. I think our fertilization program for sunflower needs improvement, especially nitrogen. We don't know what we're doing actually with nitrogen fertilization. And then again, do we have other nutrient deficiencies, like magnesium, for instance? We don't expect it. Potassium, we don't expect it. Sulfur, do we have sulfur deficiencies? And I think one way of going about it is doing a survey, looking at farmers' fields, consulting the people in the field, the people in the fertilizer business. What are they seeing? What is their experience? Yeah, Mr. Chairman, thank you very much.
Dr. Nel, thank you very much. Thank you for sharing your knowledge with us, and you definitely did not lose your touch. Ladies and gentlemen, it's lunchtime. Lunch will be served on the deck. After lunch, we will proceed, and Dr. Bredenan, the chairperson of the All Seeds Advisory, will take over as chairman of the session. Enjoy lunch. We'll start at 2 o'clock promptly. Thank you.